Visiting we mentioned earlier in the unit, okay? And terminology is very important. If you haven't picked up on that in this unit especially, terminology is very important. Make sure you learn definitions of things, okay? Right, Renji? All right. So we have periodic functions. A periodic function is a function that has a pattern that repeats, okay? Now it's not just some general pattern, it's an exact pattern. It repeats exactly the same way in a certain amount of distance along our x-axis. This kind of looks like a Batman function or something. I don't know where they got that, but that's okay. But here's the thing, if we started at 0, here, and we went to where this little pattern started to repeat, we would be over here at 4. Okay? So this little part right here is going to repeat. And I could take that and I could move that over here and I'll have exactly the same thing. I could move it over here and I'll have exactly the same thing. Or over here. Okay? This pattern just repeats over and over and over again. Okay? That pattern is what's known as a period of the function. Okay? There are two terms related here that we want to talk about. This is a period of the function, and the period is the range of x values that it takes to repeat the pattern. In other words, when we're talking about a period or the period of the function, we're talking about a numerical value. Since it started at 0 and it ended at 4, we would say the period, which we'll use a capital P to represent period, the period is 4 units. That's how long it takes to repeat this whole thing. Now the interesting thing is here, guys, I didn't have to start here at 0. If I wanted, that was kind of in the middle of this little hump down on the bottom. If I wanted to start right here, I would go all the way to here. That would still be 4 units. Okay? It's just a matter of, are you viewing the red one as the period, or you could look at this as the pattern. Okay? That's our pattern instead of the red one. Either way, though, you're going to have a period of 4. Okay? Now, we also mentioned the term amplitude before. Okay? Mentioned this term amplitude. Amplitude is half of the difference between the maximum value of the function and the minimum value of the function. Okay? Now, let's say on this graph we don't have any values on our y-axis, but let's say that we go up to 2 here. This hits 2, and on the bottom, let's say that that's a -1. Okay. So, we would say that 2 is our max value, and -1 is our minimum value. Okay? So when we're trying to find the amplitude, we'll use a capital A to represent amplitude, and we'll take the max minus the min and divide it by 2. So in this case, our amplitude would be 3/2. Now this is helpful on a couple of things, and one of those things is we can kind of find a center line. Alright? In this case, our center line would be at a positive 1/2. The center line on a periodic function, when we're just talking about a generic periodic function like this one, it may not be as helpful. But you'll see where this is helpful on the sine and cosine functions. This center line from this to the max is the period, or I'm sorry, is the amplitude, and from the center line down to the min is also the amplitude. Mine's not drawn to scale, but you get the idea. This is 3/2, and this is 3/2. Okay, so that distance there. So if you can find the amplitude, that does help you find that kind of middle line there. That's going to be an important feature to recognize once we start taking the sine and cosine functions and moving them around. Okay. Now, one other note here, and then we're going to look at sine specifically, and that is amplitude and period are always positive. Okay? They're always positive. There is going to be a temptation. Let's say we had this function and it got reflected across the x-axis. All right. Oops. Let's leave that there. Let's grab this. It got reflected across the x-axis. You guys know that that would be, you know, a negative f of x. That's what would reflect it across the x-axis. What would my amplitude be?
3/2.
It's still 3/2. So, just because I see a negative, and I'm going down now, it's not going to affect my amplitude. All right? And what we're going to see here, if I did this, what's that 2 going to do to this? It's going to expand it vertically to double the amplitude. So now my amplitude would be 3, but you need to kind of see the negative and the 2 as doing two different things. The 2 is stretching the amplitude up to 3. The negative is then reflecting this. Okay? Don't tell me the amplitude is -3 now. Okay? That's something that a lot of people will do. It's an easy mistake to make. Don't ever give a negative for the amplitude or the period. Okay? Alright, let's put this guy back. Alright. So let's use what we know about the unit circle here and come up with our graph for sine. Okay? We're going to go around the unit circle using just the pi/4s, or the 45-degree angles. Okay? I'm not going to do all the 30s and 60s. So let's run through this. Try not to use your unit circle. Try to go from memory. Okay? Try not to look at your unit circle. Use it, but use it in your head. Alright, so what's sine of 0? 0, okay? What is sine of pi/4? √2/2. Okay, it's √2/2. Now, √2/2 is approximately 0.707. Alright, so we'll put that right here. Okay. What is the sine of pi/2? It's 1, okay? It's 1, so now we're up here. How about at 3pi/4? It's √2/2 again. We're back down to 0.707. What's the sine of pi? 0. What's the sine of 5pi/4? Good. Negative √2/2. The sine of 3pi/2? -1. The sine of 7pi/4? Okay, negative √2/2. And how about the sine of 2 pi? 0, okay? And we just now went, you guys already know because of the unit circle, that we're going to start repeating our values again. So we just went through one period of the sine curve. All right, so here is our sine curve. Right. Now, one note. This is a sine curve, not a sine connect the dots, okay? And it's not a sine absolute value function, okay? So when you're sketching these, please make it a sine curve, not straight lines, okay? Am I expecting perfection? No, all right? But it should at least be curved, all right? So, now I want you to see something here, okay? Where are our quadrants on this? Where does the first quadrant end and the second quadrant begin?
At the 1 and the 0. Like, then y.
Pi over 2.
Wait, what was the question?
Oh, pi over
It starts at 2.
Like
First
when
quadrant
y equals
starts
1
at
or y
0.
equals 0, that's when your quadrant starts.
Okay, when y, okay, I get what you were saying now. When we're either up at 1 or at 0 or down at -1 are going to be where our quadrants break, okay? On the x-axis, that's going to be here at pi over 2, at pi, at 3 pi over 2, and at 2 pi, okay? Now, what do we know about sine in the first quadrant? It's positive. What do we know about sine in the second quadrant? It's still positive. What about sine in the third quadrant? It's negative, because that's t. And how about the fourth quadrant? It's also negative. Okay? See that all students take calculus? All right, here you can see it on the graph. Sine is positive in the first and second quadrants. It's negative in the third and fourth quadrants. Okay? All right, so now let's take a look at some features of the graph here. What's the domain of sine?
All real numbers.
Less than or equal.
Yeah, it's all real numbers, okay? It's all real numbers. We can put negative values for the angle. We can put fractions for the angle. We can put anything in there for the angle as long as it's a real number. So x is an element of the real numbers. Okay? What's our range?
I
Greater than negative
y is
1.
greater than -1, but less
Greater than or equal to -1, less than or equal to 2.
Okay. So we're going, it can equal -1, I heard you guys say, and it can equal 1. So it goes from -1 up to 1. Okay? From -1 up to 1. Now we already mentioned these, but I'll put them here so it's all together. The amplitude of sine equals 1. So A equals 1, and the period equals 2 pi. Good. The period is 2 pi. Notice here, I was talking about that center line. Where would the center line be? At 0, the x-axis, right? Okay. So guys, when we shift this up and down later, we're going to need to pay attention to what happens. That x-axis is going to kind of be the point, the line that we kind of use as our reference point as we move up and down. Okay? Because if our amplitude is 1 and but our x, we've translated this whole thing up 3, we've got to use that 3 as our center line, and we've got to go up 1 from there and down 1 from there. Okay, we'll practice doing that on Thursday. I want to make sure we see that now. Okay, this is just another kind of simpler sketch. It only uses 5 points, and the reason why I give this to you is because anytime you do a sketch, I want to see 5 points. Okay? You have your starting point, and then you have the 4 quadrants. Okay? So it starts at 0, 0, then we have pi over 2, 1, then pi 0, 3 pi over 2, negative 1, and then back to 2 pi 0. Anytime you draw a sine curve for me, I want you to list 5 points. Okay? You're allowed to list more, but I'm going to be looking for those 5 points. A little tip when you are sketching them, before you sketch it, you're going to identify what your period is, any translations, and what your amplitude is. So the best thing to do is start with this point here, then use that period to figure out where the last point's going to be. Okay? Because you know sine is going to be on this middle line at the beginning and at the end, and then you can find the middle because you know it's going to be on this center line there as well. Okay? So you find the start and end, find halfway between, and that's going to be your another point that's on this midline. Then you can find halfway between in this first half to get this point, and then halfway between these to get that point. All right? So when you go to sketch them, that's going to probably be the easiest way to do it. All right. Now let's do the same thing with cosine. Let's think through our unit circle again. Okay? Think through our unit circle. What is cosine of 0? 1. And cosine of pi over 4? Root 2 over 2. Okay? Root 2 over 2. So that's 0.707. How about pi over 2? 0. 3 pi over 4? Good. Negative root 2 over 2. Cosine of pi? Negative 1. Cosine of 5 pi over 4? Good. Negative root 2 over 2. Cosine of 3 pi over 2? 0. Cosine of 7 pi over 4? Good. Positive root 2 over 2. And cosine of 2 pi? We're back to 1. Okay? Now again, this is a curve. So here is our cosine curve. All right? Again, if we look at our quadrants, where is cosine positive?
The first and fourth.
In the first, because all of them are, and the fourth quadrants. It's negative in the second and third quadrants. Okay? So again, you can see that relationship there.
So the domain and range are the same for cosine and sine graphs.
The domain and range, yeah, they are the same, okay? And in fact, let's see why that's the case. Okay. Real quick before you,
The amplitude and the period
Okay.
are all the same.
they're all going to be the same. Watch this. This is why they're the same.
It's just shifted, right?
This is the same thing, right? It's just shifted over. It's shifted over pi over 2. And when did we already see that?
You know, it's
What?
About a week ago or something.
We just saw this last week. And what?
Identity.
What?
I forgot what the identity
What identities?
Oh, it was like sine plus pi over 2 equals cosine.
Nah,
Cosine squared plus
Oh.
cosine squared equals 1.
No, there was.
That's
one-
true,
there was
but-
nine-
There's 4, 2, and 4.
Nine- oh, sine.
wait.
Co-function?
Cofunctions, the cofunctions. That's why these are just shifted over, okay? Shifted over, or actually,
No way.
the shift over is why we have the cofunction identities, okay? So, when we're talking about amplitude, period, domain, and range, all of this is going to be the same because it's the same graph, just shifted over. X is an element of the real numbers. Your range is -1 to +1. Your amplitude is 1, and your period is 2 pi. Okay? So, that's it for today. Have a great day. We'll see you.